Hi guys,
Hi.
how did you
Hey.
survive
I did.
conference?
Yeah. It was a pretty busy week.
Yeah, it was much busy, and I was because I worked on so much stuff in night shifts the last couple of weeks.
Same here. Yeah.
I was very unprepared for at least two of my talks.
Same
It
here,
doesn't
but
matter.
I only had two talks.
Yeah, 1 second. Um, and are you now coming to San Francisco, or did not change so far?
No, I'm not coming to Summit.
Shame. Control center. Just try to get my lights on. Someone else? Oh, there's Mark. Okay, awesome.
Yeah. That's a shit. Hi.
Hi, Sachin.
Hey.
Are you at Summit?
Oh, me?
Yeah.
Oh, no, I'm at Summit. I'm not at Summit, so. Oh, where am I going to be?
I will be there.
Um, oh, sorry. I might be at Summit, but I'm not 100% sure just yet. It depends. We'll see. We'll see. Um, they're still working on it, so.
Yeah, let's see.
Uh,
Ah, okay, let's check who's on the agenda. Pascal
Yeah, I think
might arrive later.
so Mark put an item on the agenda.
Yeah. Can talk about that.
Yeah, thank you.
So Kamil should also, yeah, it's there.
Yep, there he is.
Connecting. Okay. Yeah, funny thing, they already posted the videos, but they made we made the push at the conference with the new GitHub channel, and then they posted it to the old one.
Oh, yeah, you're right.
But apparently they're working on it.
Yeah, because now our faces are still on the front page, like from these meetings.
Yeah. It's also like you basically don't subscribe, or it's annoying a lot of people when they just get all the notifications of the working groups. They're
Yeah.
just interested in like GraphQL in general from a user perspective. Oh, hi Benjamin.
Hello.
Okay, then we are complete. Can you add yourself also to the agenda?
Yeah,
Just
there was a conflict. I'm fixing it.
Okay. Okay, then we can get started. Okay, hi everyone. Before we get started, let me remind you that we all agree by participating in this meeting to the GraphQL Spec Membership Agreement, the participation guidelines, the contribution guide, and the code of conduct. Also, these meetings are recorded and published on YouTube, and we may use LLMs or AI summary tools. Let's start with a quick round of introduction. My name is Michael.
Hi, I'm Pascal.
Hello, I'm Mark.
Martin from Apollo.
Sachin from Apollo.
Camille from the Guild.
We have today two items on the agenda. One is an interesting problem Mark ran over that we can discuss. And the second one is about ENA merging. We have also discussed that with many people at the conference to get a bit feedback. And it would be good if we get on one point so we can specify it.
Actually, it's only Sachin which is out of the loop here. We discussed it with everyone.
So let's discuss it and then see what direction we want to take, or if we want to stick with the one which we chose. Awesome. With that, Mark, you can take it away.
All right. Yeah, thanks everyone. So I guess the video is up now already. So if you kind of missed it, the problem that I'm about to describe is I think most people here probably already know. And I linked in the sidebar here this pull 634 with kind of the two options I see. There seems to be should we say a difference of opinion about the best way to implement the solution to this edge case. One would be adding defer to all eligible fields in a selection set, and the other would be some kind of like manual schema directive to control the parallelization of fields. I realize I'm like skipping over the like what is the problem here, but it would take me a while to do that. It's kind of linked in the there's like a pull request, so hopefully everyone's does anyone here like not know what we're talking about in such case?
Probably Sachin. I don't know if you saw the problem.
I have
Maybe
no
you,
idea,
you
but
yeah, maybe
I'm
you show. He has a good document for it. Maybe you show that quickly.
There's also like the problem that you described, Mark. When we did the discussion in the other work group, I think for the people here in the composite work group, it's actually much simpler if we just describe it like you fetch all the requirements in the query and defer the rest, with the idea that you much quicker can fetch all of the dependencies and initiate the complicated fetches, and then defer essentially resolves it lazily on demand.
Yeah. That's option one, for sure. And then I think Martin was kind of hinting at option
But
two
maybe
might be better.
maybe just lay out the problem so everybody's really on the same page.
Is it possible? Oh, I guess I can share my screen.
Yeah, share your screen.
Tab.
So also for the future viewers of this episode.
Right. Yeah, when this is up on Netflix one day. So here are two source schemas. Let me plus up the font size a little bit, sorry. Okay, so here's a query, right? So I'm hitting slow field 1 and slow field 2, and these fields are slow. Maybe they're mining Bitcoin, whatever. Like they're slow, they can't be optimized. And then slow field 2 is an entity field of the bar type, which is in a different subgraph. So at runtime, this is going to show up as a waterfall, right? Like this is going to take, let's say, a second, and then we got to wait for this to yield before the router or query planner can kick off slow field 2. But there's like no dependency between slow field 1 and slow field 2. And so really the kind of like optimal way to do this would be to call slow field 1 and also presumably bar ID, and like fetch these two things in parallel. And then you would get like the most efficient, like these things could be parallelized basically. Assuming that just getting bar ID is very quick, you would be able to execute slow field 1 and slow field 2 almost in parallel, which is like the best case scenario. But because the planner will try and put slow field 1 and bar ID in the same selection set, in the same request, this thing blocks kicking off this thing. Hopefully that made sense. That is the problem statement. If that didn't make sense, I have a 25-minute long talk recently published on YouTube talking about this in very exhaustive detail. But that is the problem that we're discussing. And there's like basically two options. hopping to this tab, option 1 is defer all non-immediately required fields in the selection set. So hopping back over here again, that would be adding, like wrapping, like the router would wrap slow field 1 in a defer statement. So that's option 1, and that would solve the problem. And then option 2 is we would create a new schema directive, which would be like a signal, a hint to the query planner to say, I want you to parallelize the call of this field in a selection set. And that would also do the same thing.
And for Shin, like the previous Apollo implementation I was referring to here, like in a response to Mark's talk, was the detached directive that we used to have. Do you remember that?
From a while ago, but yeah.
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 Yeah, because basically my question looking at this and also trying to sort of extend it to more complicated queries, like individually deferring all like not required fields, like that seems like a pretty blunt mechanism, because at that point you don't really know what the most optimal way of grouping and ordering fetches would be. Like it makes sense in this example, to sort of like conceptually it makes sense to think about slow field 1 as something you want to be deferred. But in other cases, like how do you actually know slow field 1 is worth deferring? Or if you have another field from the first subgraph or a couple of fields, how do you know which fields make sense to defer together? Maybe there's like maybe 3 of those fields depend on like one underlying API fetch or one underlying database query, and it would actually be less efficient to separate them. So I think basically I think you need more control over how the query planner decides between these options.
Pascal?
I could be wrong and not up to date with the latest, greatest defer specification, but Michael can probably tell me off when I'm wrong here. But I believe that the server can decide if they want to what they want to defer and how they want to defer it. Meaning that it's actually the gateway can just defer everything, and the source schema then decides what should go together and what should be deferred. So it could actually be quite nice to just say that these are the requirements, fetch it. The rest are lazy dependencies. And then the source schema, like for example, in Hot Chocolate, we could do that quite easily. We would quite easily know which chunks are well suited for a deferral and which are better be resolved in one go. So that's actually quite nice for us.
And would you defer all those fields individually? Like would you put each individual
Just
root
one-
field under a defer?
No.
One
So
time.
there is when we discussed that, we would do that on the new defer spec, right? The new defer spec that we reworked, the current defer spec that also Apollo implements has an issue that it duplicates. And that's when we tried these first implementations out of the original spec that we came up with, that Rob came up with. We basically saw that you could cause the server immediate harm by writing certain queries in a certain way, so you duplicate a ton of data, right? You could DDoS your server quickly with it. And that's why Yakov and Rob worked on a new proposal that takes all of this into account, and that does actually query planning per selection set. And that now deduplicates. And this means we are telling the server, we basically merge out the parts that don't need to be deferred. So there is no duplication anymore. And the downstream server then could also in the original spec proposal, but also in the new one, say, no, here's no async boundary, for instance. Here's no IO boundary. So I'm not deferring that. I'm giving you that because I anyway have that in memory. So there's no, if it's implemented well, it's actually super efficient in that way. And there's another proposal like from Facebook, which says basically batch. So you can say, I want the the initial data immediately, and then I want everything else in one big batch. So you also just
the async.
that's a batch. They call it batch.
Async,
That is
async is client only.
Yeah, and the beauty of that is you get the most efficient way that the source schema says that it can deliver this, and you just get 2 updates. And I have a mini trial branch for that, and super fast also for non-blocking things, like where you just have async boundaries there, because the query executor can immediately move on. There are a couple of complexities in that, so we are refining at the moment for our implementation but it's you basically tell the consecutive steps. You can already start your work. I'm just waiting for the data to come in, because I have everything that is required for you to go on and fetch. And this, you create a much faster waterfall in the query plan execution than when you just mark out 1 or 2 fields.
Well, essentially, you make a waterfall without the overhead of other selections. So the query execution, the core query execution stays constant if you have the same requirements. So it doesn't matter what you select, like Mark showed here. It doesn't matter what fields you select. For a constant requirements, for a set of constant requirements, you will always end up with a more or less constant query execution time. Which is
would it help to get like a VS Code thing up and like sketch it out again, just so we're all on the same page?
I'm sure. I think this also works for me, but maybe other people.
I mean, the document you described, I think, makes sense. But
yeah.
So there is merit for that, but in any case, the query planning and query execution is in any case an implementation detail for the implementers, right? The question is, do we want to recommend something like that, or do we want to have that in the spec pointing out this is a way you can solve that? We can do that as an appendix or something, but like the main query planning and main execution piece, that would be in any case implementation detail.
I think right now we haven't really described the interaction with defer at all, right? So I think at a minimum that's something we should describe. And I like as long as you define this on top of like the new defer spec and with a subgraph that actually supports like taking actual async boundaries into account. Then I agree. It's a really nice mechanism because it allows the subgraph to basically be in control. I do think that also points to the need to, which we've discussed before, to basically provide more metadata to the query planner about sort of the subgraph, like what the first spec does it support? Does it support like query batching or variable batching? So I think that's potentially an area where we could add something to the spec as well.
And on this side, Benji made a lot of progress. I can ask him maybe if he has some time next week to come and lay that a bit out with capabilities feature that is coming to GraphQL. So we get more info on that, because I see that as a critical part to all of these things.
And of course, this all assumes that your subgraphs even support defer and stream and are written in an async compatible framework, which maybe is not the case, especially if you're coming from like a Python service. Like not everything's fast API. Some things are sync only. But anyway, assuming we're building for the future, if it's possible to do this with like magically at defer and not have to kind of put in directives to control it, I'll defer to no pun
Yeah.
intended. I will defer to the expertise here to decide like which is the best approach. But then having like something in the spec would be really beneficial, because I think either which way we go with this, it's clearly sufficiently non-obvious and a bit tricky to warrant something. And then like the risk is if we don't implement this, you'll get teams like kind of what we had internally, where they're like migrating to Federation and it's just strictly a worse experience because they get this loss of concurrency that they got without Federation and without GraphQL, and they're like, wow, this thing's whack. So like having like something that we can point to in the spec, even as a note, would be like swell.
And I wonder if like is the defer approach like the only thing we would need to specify, or do you still see use cases for like your original approach? Like you described split schema as sort of the approach you're currently taking, which puts the query planner in control, like basically like splitting a query up in like multiple subqueries. And
Right.
that's similar to the approach we took at Apollo in sort of the early Federation days with detached, where we're basically telling the query planner, like don't try to put all these fields into one subquery to the same subgraph, but actually split across these boundaries if you encounter them. And I think there may still be use cases for that as well. Like it actually guarantees that things are executed as separate subqueries. But if you can rely on your subgraph to support the most recent defer spec in a performant matter, then like that's strictly more performant and avoids the need to add these explicit directives.
Yeah, so I don't know is the answer, and I think what I'd like to see is just some more of these sort of sample foobar use cases. Let's start with the assumption that defer can magically solve everything, because that would be ideal, right? Like if we don't need to do any directives at all, that would be great. It's just magic, it just works. Yes, a directive would allow it to work with non-async subgraphs, but like let's just pretend they don't exist. We're building for the future here. So ideally, if we can start with the assumption that defer works, great. But then we can try and write out some sample schemas and queries that breaks that assumption. And then if we're like, oh yeah, actually we do need a directive, then sure, we kind of write up a directive. And then the directive, like what we do today is we split it into a separate schema to force a subgraph, to force the query planner to send it to a different subgraph. Obviously, we wouldn't need to do that if this was a spec directive. It would just be a signal to the query planner to just like by itself send separate requests rather than having to register two different subgraphs. So that's kind of how I would see things ideally. Does that make sense?
Yeah, it does. Like I think the one thing on my mind is like I'm trying to think of use cases where the separate subqueries case would still be beneficial. The one thing that comes to mind is caching. Like if you're actually caching subgraph responses, like it might be beneficial to treat them as separate requests, because that, like, depending on sort of your implementation of caching.
Right. Yeah, I feel caching the query as a whole rather than individual resolvers. That feels like a whole separate like half hour or hour long discussion. But yeah, I can see that being a
But
thing.
like in your example, if like I can imagine it being beneficial to cache like slow field 1 separately, and to make that a completely separate request. And maybe it's really slow, but it hardly ever changes, right?
But that would be like a whole different story. I think like if we talk about caching, this should be a different different way to describe that.
That's where I'm at with this whole thing. Like what you showed us, Mark, is that there is this edge case, which is a problem. And there's multiple ways how we can approach it. I think what we have to do, though, is for the specification, we have to describe the execution in a way that makes people aware that there are these challenges that we have in execution and that they can be solved, but they do not have to be solved to be spec compliant. Like it's similar to how do they call it in the spec in the graphical spec, Michael? That as long as the observable result is the same, the implementation doesn't matter. And here it's similar, right? As long as the actual request that the result of the request is the same, I think the execution, how it's executed, shouldn't matter. Because, for example, the split query could also be part of the sub-specification of cost. Like we could make a sub-specification at some point that we say there is a cost involved in resolvers. And based on this cost, you can actually automatically split the queries so that they include or run certain things in parallel. So I think that the solution to the problem is to be aware of the problem and let the gateways fix it in their own way, and then use a proper sub-specification, either the caching sub-specification, the cost sub-specification, or whatever, as a potential solution for it.
Just as a note on cost, because I've seen the GitHub thread on that. I was hoping to avoid us needing to depend on that in order to do this. But if we did need to start kind of looking at how expensive resolvers are, and of course, as a human, applying something like split schema, you would need to know, like you would need that mental model of this thing blocks this thing's not can't execute in parallel. So you do need to see that data, you do need to see that waterfall. And the way that we do it, the way that I'll go out on a limb here and say everyone should be doing it for building for the future is through open telemetry, right? We're trying to be good citizens with OTAL data. And so I know we already have like a OTAL working group. I don't know if there's some like automatic layering that we can put on top of OTAL traces to kind of provide a signal for this.
I wouldn't do this. I would. So I had similar ideas, but I always end up with it's a very dangerous thing to do this automatically. But what you could do is you could statically emit. So you could essentially have your open telemetry system, which collects data, and once a month or once a year or whenever you want, you run a script which essentially emits and tells you what resolver have what cost, and then you statically add this to your schema if you want. But
that has a lot of issues, Pascal, because open telemetry is backward looking. And let's say you are just changing your whole implementation, and now you're getting all these penalties because it's backward looking on the traces. So I don't think open telemetry is the solution, as you could in the next PR have a very different behavior. And then you wait basically for new telemetry data.
But essentially it's a runtime information that you add to your cost planning, right? It's not that, I mean,
the cost planning is also like if you go for the IBM cost spec that Apollo and also we implement, then there are a lot of defaults. Like the cost specification has a lot of algorithms in there that apply default cost to your system based on how you build things. There's also what you can do is again take async boundaries into the context of this and then infer cost. Come in.
Oh yeah, I just wanted to say that like the cost, I already spoke with somebody, I think it was with Martin, that it's, as you said, like the cost, like the fact that you introduce, let's say you change the field, the resolution or whatever, right? Or like infrastructure under it doesn't really matter. And from this point in time, it's slower, right? Then even like spike in traffic or like a failure in the system or whatever will affect the execution faultily, right? Because, you know, it's slow, but it was slow because of an accident or whatever. And now the query planner will think it's slow. So from my point of view, like we should always aim to have it explicit So you as the developer know that like this field is slow. So you slap a directive and say, I know it's slow, treat it as a slow period. Also about the cost. So or like even splitting the queries. There's the cost of splitting the query because you have to like execute twice, right? Even if it hits the same router, even if it's the same subgraph, even if it hits as parallel, you know, 2 parallel requests, you don't share the data loader, so you rely on caching and, you know, so on and so on. And the defer pretty much in this case is like a perfect solution because you share the entire thing. You just yield the needed field as you know, when you need it. Also, from the query planning perspective, ideally, the query planner should be field driven. So there should be like a dependency between fields and not dependency between calls. So if you have like a fetch, like a, let's call it fetch call, but like, I don't know, like a HTTP request to a subgraph, right? That fetches like 200 fields, but like 2 of them rely, like 2 of them are the dependency of another fetch call and the rest is not, or like, you know, it's like more complex and all of that. Then once you have those fields, you can move on, right? And execute something else. With 2 splitted queries, it would be a bit different. It will be more efficient, but it's still not the best, you know, efficiency. So it's just like require a lot of changes, and defer is like, I don't know, it feels like the best approach here, to be honest. I see no other that like can compete with defer. Also, deferring string by default, all of those, I don't know the new spec, couldn't find it really, what they do.
I can post this later in the Composite
but also,
channel.
I wanted to say that like being explicit is just better. Even so, we discussed it like, let's say, oh, you want to be explicit, right? And then you don't want to defer like 2 fields separately or, you know, together or whatever. Then you could have like, I discussed it with Mark, I think, and Martin, which is to put like a label. And this label means, oh, if you want to fetch this slow field and the other slow field, but they share the same execution or like the data source, you batch them and you execute them at as one, right? And then it's even simpler. And then you just slap this one directive here and there, and it just works.
The thing on that, just coming, is that with the other thing, it's really the source schema that becomes control over what is slow and not, because it could just say, no, I'm not deferring that because it makes no sense. And what defer actually does is not saying defer this field. It's just telling the downstream system that this is not the most important data. Like basically you say, I can already work with this initial data and all the other data is not as important for my work. That's what you're saying.
Yeah.
Okay, awesome. That is one of our famous 15-minute discussions.
So,
30.
so what is the kind of like takeaway from this then? What is the action item here?
So the action item is we should have an appendix. That's what I think resonated the most. An appendix to the specification that lays out the problem and proposes a solution to this. Says basically this can be solved like this, but it's in the end up to the implementation to implement it like that. Right? It could be like a multi-phase thing even. Like think about Apollo Federation, for instance, the router might want to allow for more backward compatibility and has like a staged mechanism where it defers for new stuff, but splits for old stuff. There could be multiple possible implementations. I think having it just as an appendix, describing the problem and the possible solution will make implementers aware and make sure that this problem is known. You are muted.
Sorry. And then, like, as you say, provide both kind of suggestions, like do the auto defer thing for new compatible things and some kind of directive, which we'll make up a name for like old things.
Yeah, we need to go, like, defer also has a cost, right? Everything always has a cost. That's why we also need to verify that everything works like we discussed, and then also make people aware of that, right? So it could be that if you don't have this problem, that the standard query planning could even work out better for you.
Okay. Well, I take issue with that last bit because then it's not up to a like framework author to decide if it's going to be a problem or not for like actual people using the framework, because it might not be initially, but it might in the future. It seems, I don't know, relatively easy to run into. But I kind of like the overall suggestion here of just having it as an additional appendix or something like that. Is this something that you would like me to try and take a stab at? I'm happy
Yeah, if you
do
want
so.
to, just go ahead.
Just to get us started. Okay, I can.
Yeah, you see where the spec repository is, and we can just like if you have an initial proposal, we can discuss it further.
Cool. All right, I will take a step.
It's awesome.
Thanks.
Awesome, guys. Then I have another agenda item. I'm going to take over the screen.
Why do your borders look so weird?
Oh, it's a new.
Why does this look so weird?
Shut up. It's a new macOS. Okay. So we discussed several times this little bit. We have an enum. Right. And let's say this is subgraph 1. And then we have 1, 2. Okay. And these enums across downstream services has different values, enum values, right? And the current decision we had was, but there are two competing proposals actually, which lead to the same thing. We talked about intersection, where we would take these two enums and basically say we take the intersection of this, which in this case would be just ABC. And then this is what we expose to the outside world. So I discussed this also with Lee a bit, because like Netflix has an interesting approach here. They do basically this thing. And then they, if they get on the output side, either of these values, they just pass them through. Because their assumption is that the gateway doesn't have to throw an error here, because clients anyway have to guard against future values.
What about inputs?
Well, that's the approach. So I think you have to start from a different angle, Michael.
Okay.
I think you have to start with what Apollo does at the moment is that input only enums work with intersection, right? And output only enums work with union. And the mix, where the mixed ones, they have to match exactly. And this is 3 behaviors for the same graphical type, which is really confusing. Now,
Yeah,
what we discussed, like the intersection was something that we once came up as an idea, but we threw it away quite quickly, because as soon as you have intersection, your question, what about enums, what about outputs, is actually right, because you will get runtime issues. Now, what we decided in the specification, just so that we all are again on the same page here, is that we decided that we do only exact match, and you have to exclude everything with inaccessible. That doesn't match. Otherwise, you will have a composition issue. And we did this so that we have the flexibility to choose whatever we want down the road without having a breaking change in the specification. Now, the thing is that we've discussed this a lot with people at the conference, and we had a few discussions also on Slack and whatever. And we always, like, Stephen made an interesting point, and he was like, well, there's always going to be runtime exceptions if you validate it, even with your approach. There's a window between the subgraph deployment and the gateway deployment where the subgraph can return something that the gateway doesn't know, or yeah. So in the deprecation case,
even with that, even with this, you're just hiding it from the schema, right?
Exactly. So technically, there's always going to be the case of runtime errors. Now, what they did with Netflix is they worked around this, and they just said that, well, we don't care. And I was like, what? But they don't care. So they just say that on the client side, you anyway have to safeguard against future values. That's how you implement the client, because otherwise you're locked in.
So at the TSC dinner, we got feedback from the Meta guys and also from Lee that he agrees on that, because that is the best practice in GraphQL anyway, to guard against future changes. Adding an enum value in GraphQL is a dangerous change, because clients always get suddenly a value. Think about compiled clients in Kotlin or whatnot. They suddenly get a value that they don't understand, have no type for. So best practices is in any case to have like an extra item on your enum that you map it to and say, okay, I'm guarding against this future value, because this is a future value.
But that's true for outputs, right? For clients.
Yeah.
But what about subgraphs that have to deal with inputs that they are not?
They don't care.
So that's now the interesting thing. Logically, when we don't have to care about outputs.
Yeah, but I mean, the inputs don't care, Pascal, because intersection means the values we don't know about.
Let me finish.
Okay.
Logically, like that's why I started in the very beginning with the approach that Apollo does. Logically, if we don't care about outputs, we don't have to care about outputs. So we just use intersection, which is the input behavior. It's always going to be inputs. It's always going to be intersection. And then
it's basically,
you have a very, very simple rule that you apply. It's always going to be intersection.
But I might be missing something here, but is intersection actually safe? Because,
yes.
For instance, if subgraph 2 has a field that takes foo as an input, but you pass DEF to it.
You cannot, because it's intersection. Intersection is that. You just end up with the values that are available on both subgraphs.
Okay, so we do restrict, but then, wait, what about the output then? Like what
the output is the assumption is GraphQL clients anyway have to gate against future values. So that's basically what Netflix does in their gateway. They just pass it through.
And if you want to have a shared output type, which is if you want to have a shared output type, it's you have to essentially have it on all subgraphs.
So the typical, because the typical workflows at companies that deal with this is that one of the downstream systems introduces here a new value, like DEF, for instance. but it's not yet available on the second subgraph. So there is a window, even if we work with inaccessible, that this value is there, and also this team already could return it. And per course spec, you should guard for these kinds of future values, because this is a future value that will be there as soon as the second team said, okay, we are now ready, we introduced that, and now world is again fine. We are aligned again.
There's one important piece to this. This all comes from the assumption, that's what we now say, the assumption that the final state of your federated system is going to have, like, you try to get the same enums on all subgraphs. That's like, there's two different ideologies that you can follow. You can say that I have output only types, so each subgraph only defines the outputs that they use in these enums, right? Or you go the other way, what we see, what the big players actually do, like Netflix, they have a shared library. And all of the subgraphs essentially just include that. And it doesn't matter in what language they are written, because in the end, it's an STL file, so it doesn't matter. But all the subgraphs essentially have access to a shared collection of value types and
yeah, but they not only have shared types, there are also types that are only owned by a single subgraph, but we don't care about them.
It's just that I'm saying, like, this all comes from the standpoint that we converge the system to a state where all the enums are the same across all of the services.
Yeah. That is a pretty big assumption, though, and I also do worry about backwards compatibility, because if
backwards compatibility is quite easy, you just have to make the enums available on all your subgraphs. That's the problem solved.
Sure, but that can be a quite involved operation if that's not your starting point.
Just 300.
Yeah, but
I'm curious to hear Sachin's take on this, because you've been most closely involved in the implementation.
I don't feel good about it. It feels basically like we're trying to get around making output enums and enums be separate things. Because you have this weird world where your schema sort of declares it only accepts one thing, but then outputs different things when you actually ask it about it. And I worry some people might start relying on that behavior as the other half of it, right? Like some people might start relying that they get DEF out of the thing implicitly when it happens. Then you basically have a world where you're basically making this enum mean two different things in two contexts and just not saying it out loud. Is kind of what it feels like. But I don't know.
Why do you mean,
I think that comes down to the assumption again that, like, this is a temporary state and you'll want to end up in a consistent state. But I'm just not sure, like, how true that is.
That's a big assumption. I don't necessarily know if that's true all the time. It really depends on the teams working in the composition or whoever.
The pit of success. Sometimes it's also just a pit, and you have to push people into it, and you have to see if they survive. You know.
It would be nice if you guys could maybe take it as a discussion point in Apollo, or maybe even ask a couple of customers where you think that is not the case. Like we looked, like for instance, Stephen gave us an anonymized schema kind, so where we could analyze how the usage of Netflix is across these types, right? And this is based on that. So it would be interesting to see how other people manage with it, because the current way we thought about that is like the current spec proposal that we have, right? Is that we said we're gonna introduce here inaccessible. It's still intersection, right? Just that you manually intersect. So in the but it's kind of like that, Pascal, because it's not a union that we have.
No, it's
union is gone.
Exact match.
Yeah.
It's not
Yes, but what you're doing here is a manual intersection. You're bringing it to that state. The outcome is the same. So it would be great to have more input on that.
Yeah, and in Paolo's case, what would happen here is if you see DEF from the subgraph, the router would essentially give an error for that field, saying that the field misbehaved, I think, if I remember correctly. I'm not 100% on that, what the error messaging is, but yeah.
I mean, it depends how the enum is used, right? If you just, what's the default behavior of an enum? If you just, it's not composed, it's going to be ripped out of the gateway, right?
It's a good question. I'm not sure what the default if it's not used anywhere. So
yeah, so it's just gonna go.
Yeah, so what we're gonna do is we're gonna follow what Netflix does when we pass it through. We even get a note in the crossback that we are allowed to. So that's what we negotiated in the TSC dinner.
Yeah, I mean that's anyway.
So it is.
But it's independent. It's independent from this merging algorithm because we anyway have to do it because otherwise you get weird runtime exceptions during deployments. So it's anyway something that we have to do. We have to loosen up the validation here because it can actually happen anyway. It doesn't matter which approach we choose. So.
Yeah, it's anyway, like if you write a professional GraphQL client, a UI, you have to guard against this in any case. Like there's always the version where your mobile application is deployed and your backend changes and provides new enum values.
I have one thing because I see that Sachin is still conflicted with the validation on the gateway. So let me give you one example. So let's say that you have enum foo on two subgraphs and it's used in input and in output, both directions. So now you want to phase in a new field, right? So you start phasing it in. That means that you have to make it inaccessible on at least one of the services, and then you start deploying it through all of your hundreds of subgraphs. And then eventually you remove the inaccessible. That can take weeks to get it done. And it's very likely already the case that someone thinks that, hey, this new field, this new enum value, I now want to return, and they just return the value. And when they return the value, then everything blows up. So it's for this case where you have shared enums, you can actually have the issue that for it's not only deployments, like you can have this state for weeks that it's not in the schema, but someone actually might already return it, because that's exactly what Netflix ran into, right? Is that it's actually not only during deployments, it can actually take longer, way longer. So that's where you have to loosen up the validation a bit. Not on the input though. The input is validated. You can't pass in arbitrary stuff in the input. Only the output.
Kamil, what are your thoughts?
Honestly, about the enums, I have zero thoughts, to be honest. It's I mean, from my point of view, the current behavior that it is in Apollo, it's sometimes hard to understand. Like when you do composition and like query planning, but like I don't know.
Yeah, especially if you go from an out, like what I found surprising when I read it is when you go from an output and make it now input also, and like the union suddenly collapses.
Yeah, but like what about the default values?
Okay.
Like when somebody adds in the schema like a default value that points to an enum value that is not shared, let's say, not part of the intersection, I know.
Yeah.
You know, then we like error that in the composition.
Yeah, there's an error, I think, for that there's a specific error rule that
Default value cannot be accessible.
invalid enum. There's a validation rule for that.
I mean, that makes sense. From the output, I had no idea. I mean, from the input also, like if there's a subgraph that cannot understand and they have, you know, you have, like Martin said, you have multiple fields being contributed by multiple graphs with the same name, and they have different like inputs, then you do want to have the intersection, right? Otherwise it would just blow up. For the output, I have no idea. I mean, if we pass it as an error or not, I don't know. I have no opinions there.
Yeah. So with the how do you do it in Apollo? Do you mark them as input only enums?
Input only? What do you mean?
Yeah, in Apollo you have these three behaviors. You have
Yeah,
enums
but
that
like,
are used on the input.
but from
on
the public
out-
schema perspective, there is no differentiation. It's just that
Yeah,
like,
yeah. But like kind of because I find this different behavior surprising. If you move, if you start moving an enum suddenly on the output or suddenly on the input side, because it changes totally how the surface of the enum if you have a difference in enum values, right? So is there a mechanism where you say this is input only?
not really. It's just that like the public schema, it's from the public schema perspective, like the consumer of the API, you just see the enum in, you know, the shape that is the same as for the output. So then you cannot really do the input in a different way, you know?
As far as I know, the behavior depends purely on how the enum is actually being used.
That's correct. It depends purely on like how it's used in the schema. And it's not annotated as to which behavior it is in the supergraph. It's just sort of, it's more of a composition thing, I think. We do keep track of like which subgraphs have which enum values, of course, but you know,
So how should we proceed on that? At the moment, it's like defined like this. This is
Yeah.
exact match.
I mean, the intersection behavior makes sense to me. I would want to understand sort of the implications for backwards compatibility, and whether we're missing sort of a use case that isn't about convergence here.
Can you discuss it maybe with your colleagues also, get more feedback on that? Because like, how do we want to get feedback on that?
yeah. The other slight thing. The other slight thing, the time scale of convergence is something that's also a bit like tricky. Like conversions can take a very long time. I guess someone already mentioned that, but I don't know. Everything still has to sort of work while you're converging, however long that ends up taking. Or if there's arguments along the way of like trying to support an enum value in a subgraph and it takes a while. You know, but yeah, we can probably try to take a look there and see if anyone has specific opinions among customers. So
yeah, I mean we are biased by Stephen. That's why it would be good to get other opinions on that. Why maybe it makes sense to do it differently.
Yeah, I'm open for all of the things.
Can we like write it down? I mean,
yeah,
like explicitly say, you know, what the Netflix is doing and why, and then because then we can, then it's easier to understand.
The AI will do this now for us while we talk.
Already doing it. No, I can talk with Stephen, and then we can just write it down, and then maybe post it before next meeting, so that everybody can read through it.
Sure, I could share it with my team, and then you know we can discuss it internally as well.
Okay, that would be good. And then also, like, if you have feedback from, I mean, if there are customers that rely on union. It would be interesting to see why, or what their thought process is there. Awesome. Then we are at time. And I'm gonna look that we get this one done and then discuss it next week.
Sounds great.
Awesome.
All right.
See you guys.
See you next week.
Bye.
Bye.